inside the atom. The particles within an atom are called subatomic particles. There are three fundamental particles of the atom. They are the proton, the neutron, and the electron. Some properties of the three particles. When you make this chart, I just want you to change this to say relative mass, because we're going to talk about relative to one another, not their actual mass. So when I'm looking at the three subatomic particles, we're going to talk about the electron first. The charge on the electron, every electron has a negative charge, and the symbol for the electron is an E with a little negative sign. And the mass, the relative mass, is 1/2000. So it's super light and super small. And we find the electron in, just like you learned in the history of the atom, in energy levels surrounding the nucleus. The proton has the opposite charge to the electron, so it's a positively charged particle. And so we give it the letter P with a positive sign. And the relative mass of the proton is 1, so it's one of the heavier subatomic particles. And we find the proton inside the nucleus. The neutron is just like it sounds, neutral, so it has no charge. The symbol is an N with a little 0, which indicates the no charge. Its relative mass is the same as the proton, so together the proton and the neutron make up the mass of the atom. And we also find it inside the nucleus. Now for this next part, I want you to pull out a periodic table and have a look at one of the squares in the periodic table. When we take a look at the box in the periodic table for carbon, we notice that there are two numbers, a 6 and a 12.011. It's important for you to note that the standard atomic notation is not the same as what you see in the periodic table. The developers of whatever periodic table you're reading get to put the numbers wherever they want in their periodic table. That's not true for standard atomic notation. Standard atomic notation is exactly that. It's a standard way of writing the information for an element so that everyone understands. So the atomic number refers to the number of protons inside the nucleus. Now remember when we talked about the development of the periodic table and we said that it's in order of atomic number. So that atomic number refers to the smaller of the two numbers. So in the periodic table for carbon it's 6, for oxygen it's 8, and so on. The mass number refers to the sum of the protons and neutrons. So remember I said that the mass of the atom is made up of the protons and the neutrons? Well, that's where that mass number comes from. Now, it's not exactly this number. It is a rounded off version. So we take the decimals and we use proper rounding rules, and I can have a mass number of 12 for carbon. Now, it's important to note that you notice down here, the same element, carbon, has a different mass number. That is possible, and we're going to talk about those in a second. Those are called isotopes. So if we're trying to find the number of protons, we know it's equal to the atomic number. If we want to find the number of neutrons, we have to subtract the mass number minus the atomic number. So this is what standard atomic notation looks like. So when we're looking at standard atomic notation, we find the mass number is always the number at the top. It will always be the biggest number if not the same number in the case of hydrogen. The atomic number will always be found at the bottom. Oops. And then here we have the element symbol. So if I want to find the number of protons, I look exactly to the atomic number. And so the number of protons in that particular atom is 6. The number of electrons is going to be identical to the protons because an atom is electronically neutral. So the positives have to equal the negatives. There are ions, which we'll talk about in a day or two, that are a little bit different, but for an atom, they're neutral, so the electrons are equal to the protons. For the neutrons, here's where we talked about doing the subtraction. So I have to take 14 minus 6, which in this case gives me 8. So that means in that particular atom of carbon, there are 6 protons and 8 neutrons inside the nucleus, and 6 electrons in energy levels surrounding the nucleus. Notice again that that's different from the standard atom of carbon, the one you saw from the periodic table, that had 12 as the mass number and 6 as the atomic number. Let's talk for a minute about why those are different. So some atoms can contain a different number of neutrons. These atoms are called isotopes. Scientists use the mass number to distinguish between isotopes. So again, remember we talked about carbon 12 and carbon 14. 2 different atoms of carbon, but they both have 6 protons, so they are both atoms of carbon. The mass of an atom is called the average atomic mass. And is measured in atomic mass units. The atomic masses on the periodic table are what we call a weighted average of all the isotopes. So for carbon, it was 12.01 because if I take all the carbon atoms in the world, most of them are carbon 12. So that puts the mass closer to 12 than it is to 13 or 14. So another example down here is lithium. Lithium-6 and lithium-7 are 2 different isotopes of lithium. So if I look in the periodic table, I see that the average mass is 6.94. So what does that tell me? It tells me because that mass is closer to 7, that there are more lithium-7 atoms on Earth than there are lithium-6. Okay, now let's look at how to do this for all of the atoms on the periodic table to figure out their protons, neutrons, and electrons. This is called the atomic structure of the atom. First, you're going to want to create this little chart in your note so that you can fill it in with me as we go along if you haven't done that already. So essentially there are 4 columns here for 4 different elements. And we're going to look at the different atomic number, mass number, protons, electrons, and neutrons. So you should be able to do this regardless of what spot in the chart that I've filled out for you, because all of these numbers are related to one another, just like we saw in the last slide. So let's start with nitrogen. So the atomic number, remember, is the number that we find at the bottom. So for nitrogen, the atomic number is 7. And remembering that the mass number is the number that's at the top for standard atomic notation. So that number for nitrogen is 14. Remembering how to find the protons, neutrons, electrons. So the protons are equal to the atomic number at the bottom. Remembering that the electrons are always equal to the protons. And then the neutrons are equal to the mass number minus the atomic number, which happens to be the exact same as the atomic number for nitrogen. So nitrogen has 7 protons, 7 electrons, and 7 neutrons. Let's try aluminum. So aluminum would have, you guessed it, 13 as the atomic number. The mass number for aluminum is 27. How about the protons, neutrons, and electrons? Do you think you can do that one all on your own? Good job. 13 protons, 13 electrons, and 14 neutrons as I take 27 minus 13. Okay, the next two are a little bit harder, but not too much. If we take a look and see that for this next atom, it's telling us that there are 17 protons. So we have to make the connection that the number of protons is exactly the same as the atomic number. So I know that there are 17 protons, means the atomic number is 17. So now I'm going to go to the periodic table and I'm going to search out which atom has atomic number 17. Did you find it? Yep, it's chlorine. So the element I'm looking at has mass number of 35 if I round it off properly. So 35 is my mass number, 17 protons was given to me. I know that the protons is equal to the number of electrons, so I've got 17 electrons. And now I have to do my subtraction. 35 minus 17 gives me 18 neutrons. Okay, do you think you can do the last one all on your own? That's right, it's neon. Atomic number 10, mass number 20, and then 10 protons, 10 electrons, and 10 neutrons. Good job. Okay, I've given you some practice in your textbook on page 240, number 1 to 6, which is going to, again, just reiterate what this lesson has said. So please read the section along with doing those questions. And I've also posted another exercise just like this so that you can practice finding the number of protons, neutrons, and electrons. Have fun.